Okay, so we are going today to review solving one-step equations with all operations. We're just going to tie together what we've done the last 2 days. And we're also going to talk about what to do if you have some fractions and decimals. We're not going to do a lot with this, but we do have to deal with this because that's how they come up sometimes. Tomorrow, you guys are going to have a short quiz on one-step equations, so we'll finish off our week before you go and eat turkey the next day.
Cool. I'm going to Ohio.
Okay, in order to solve, guys, Thanksgiving is Thursday, but we're not going to talk about it right now. We can have talk and tell time after we're done. In order to solve one-step equations, remember we use inverse operations to undo the given operation. So if we have addition and we need to get rid of addition, we do the opposite, which is subtraction. If we have multiplication in our problem and we need to get rid of multiplication, we do the opposite, which is division. Good. Now, I wanted to show you some examples. They don't always look the same as all the problems that we've been doing. Sometimes the variable will not be first. Sometimes the variable won't even be on the left side, and we can have multiple letters. We're not always going to have x. So if we look at our first example, we have 7 plus m equals 10. We still want to get m by itself, so we have to get rid of this 7. This 7 is a positive 7, so to get rid of it, volunteer to tell me what I would do to get rid of it. Hillary? Subtract 7. So I'm still going to subtract 7 from both sides. Please make sure you are taking the notes exactly like I do. I'm very particular with how I want you to show your work. So make sure that you are writing the -7 directly underneath each number to show that we're doing the same thing. Remember, our equations need to be balanced. If we take away 7 from one side, that side gets lighter and our equation is not balanced anymore. We have to take away 7 from both sides and it's still the same equation. On the left side, we have m left over. On the right side, 10 minus 7 is 3. So m equals 3. And remember, we can check this in our original equation. We can say 7 plus, if I evaluate this for 3, it's 7 plus 3 equals 10, and that's true. Okay, next one, we have -9 plus a equals 5. Now the 9 is negative. So, Jonathan, what would I do to get rid of this -9?
Take the -9 away.
And how would I take away a negative? What do I do when I take away a negative? Addition. Good. So I'm going to add 9 to both sides. So I'm going to write +9 on this side, +9 on this side. -9 plus 9 is 0. So on the left side, I'm left with a equals 9 plus 5 is 14. Some ghost writing going on there. Okay, next example, my variable's on the right, but I'm still going to do the same thing. I want to get y by itself. I need to get rid of the -2. Hannah, how do I get rid of that -2? Divide by -2. And I need to do the same thing to both sides. 6 divided by -2 is -3 equals y. Okay, next example. Spencer, I have 3 minus x equals 4. I need to get rid of the 3. How would I get rid of the 3?
Negative minus 3.
Subtract 3 from both sides. So I have -3 minus 3. I end up with, this one's a little bit tricky. I have a negative sign in front of the x. So I end up with -x equals 1. This is not good enough. We can't solve an equation and be left with -x. Let me ask you this. If -x is 1, what do you think regular x equals? -1. So x equals -1. We just kind of switch the signs around. Because if x was -1, then a negative x, or -1 would be +1. Okay, next slide has 4 examples for you to try, so I'm going to pause the video while you do that. Why is this not working? Oh, it is. Okay. Okay, Jenna, what do we do with the first one?
-a by both sides and b equals 17.
Okay, we're going to subtract 8 from both sides. We end up with b equals 17. Hopefully that all finishes writing. It's going to be really slow. Okay, let's go on and talk about the next one. Olivia, what do we do to get rid of the negative 3?
Plus 3 to both sides.
Good. Add 3 to both sides. I love how you guys are remembering to say both sides. Good. What do we end up with? W equals 20. That's a major lag today. That's challenging for me to write. All right. Hillary, next one. What do we do?
Wow, you're magic.
This one. What do we divide by? No, careful. We want to get rid of this 7 in front of the G. So we have to divide by 7. Okay? Whatever is with the variable, that's the number that we want to get rid of. So that's the number that we need to divide by. Okay, what do we end up with when we do negative 14 divided by 7? What's that? No, we have negative 14 divided by 7. Yeah. Negative 2, there you go. So G equals negative 2. Okay, questions about these so far? Do you see, Johnny?
I failed.
Do you see what to do?
Yeah.
Okay.
Whoa.
Brian, next one.
Wait, I have a question.
Okay, wait, back to the other
How does
question.
that be a positive 7?
We're dividing by the positive 7 that's in front of the G. So we're dividing by positive 7.
Can we write that the other way?
Yes, if you wrote G equals negative 2, that's fine also. I need everyone's attention up here. Okay, next one, Brian, tell me
I
what
said
to do.
x equals 7.
Well, I need to know what to do, so I don't want the answer yet.
You need to put 6 under negative 6 on both sides.
Okay, so I'm going to add 6 to both sides. And I get what?
You get x equals 7. Yeah.
When I add 13 plus 6, do I get 7? You correctly told me that I need to add 6, not 20, 19. 19. So we get negative x equals 19. So Brian, if negative x equals 19, what does x equal?
Negative 19.
Negative 19. Okay, any questions about anything that's up here? Sammy? No? Brian?
How's it addition when there's a subtraction sign?
We are undoing subtraction. So we need to do the opposite. We're using the inverse operation, which is the opposite, to get rid of the negative 6, because we want to get the x by itself on that side. So we're always going to do the opposite of what's up here. In our first problem, we had a positive 8. We did the opposite. We subtracted 8. Our second problem, we had a negative 3. We did the opposite, and we added 3. In this problem, we had 7 times g. We did the opposite, and we divided. Okay? Any other questions? Okay, let's go on to objective 2. I think I'm going to try to reset my... Right. Objective 2 is solving one-step equations with fractions and decimals. We're going to start with decimals. We need decimals because when we're doing real-world problems, we have lots of decimals. Most problems are not just simple whole numbers all the time. We've got a lot of decimals. Here's an example of an equation that we might write using decimals. Lisa has $6.75 saved. She wants to buy a new pair of sandals for $15.99. How much more money does she need to save? Well, if you weren't writing an equation, you would probably just say, oh, well, we're going to take $15.99 minus $6.75 and we'll get our answer. When we're writing an equation, we're representing it with an equation, what we do is we say, she has $6.75 plus she's going to spend some more, we don't know, or she needs to save some more. So that's our plus x because we don't know how much she's going to save. And that's going to be a total of $15.99. It's pretty easy, really, when you're solving one-step equations, not to even write an equation and to just solve the problem. But later on, when you're doing two-step equations, it's easier if you write a real equation. So to solve the equation that we have here, what would we do first? Caitlin?
You want to subtract 675 on both sides.
Good. Subtract 675 from both sides. We get x.
And you get the answer of $9.24.
Good. $9.24. Any questions about that? Okay, let's try another one. We're just going to do this together to save time. Samuel runs 3.75 miles every morning. His goal is to run 15 miles each week. How many days will he need to run each week in order to meet his goal? Well, if he runs 3.75 miles every morning, we need to take this and multiply by the number of days to get the goal. And that's shown by this equation. We have 3.75 times x. X represents the number of days, and that's going to equal a total of 15 miles. And what would we do first to solve that equation? We have to get rid of the 3.75. Jenna?
Divide both sides by 3.
Good. This shows multiplication, so we're going to use the opposite of multiplication, which is division. So x equals, anyone do 15 divided by 3.75? Mackenzie? X equals 4. So our answer to this would be that he needs to run 4 days each week in order to meet his goal. And at this point, I'm going to give you the equations. When we get to two-step equations, we'll really be working a lot on how to write the equations. Okay, fractions with multiplication. If you have, and this comes up a lot, if you have an equation where you have a fraction times the variable, we have to, in order to undo multiplication, we have to do division. Well, when you divide by a fraction, that's the same as multiplying by its reciprocal, remember? So if we multiply by the reciprocal of this fraction, that gets rid of the fraction. So I'm going to multiply by 4/3, and I'm going to do the same thing over here. I'm going to multiply by 4/3. I'm going to change this 12 to 12 over 1, just to make that a little easier for me to do. Now, if you know how to use the ABC button on your calculator, you can use that to multiply fractions. I don't need the ABC button. I never use that, so I'm not going to resort to the calculator. I'm going to show you how I would do it. This just becomes x. When we multiply a fraction by its reciprocal, our answer is 1. If I were to cross simplify here, I would get all 1s, and I'd get 1 over 1, which is just 1x. So that's why multiplying by the reciprocal gets rid of the fraction. Now over here, I'm going to look to see if I can cross simplify. 3 goes into 12 4 times. So now on top I have 4 times 4, which is 16. 1 times 1 is 1. 16 over 1 is just 16. So this is telling me that 3/4 of 16 is 12. And that's true. If I divided 12 into 4 parts and then I got 3 of those parts, it would be 12. Okay, let's take a look at the next one. Caitlin, what would I multiply by to get rid of the fraction in front of this variable? Good, I would multiply by 3 over 2. Okay, I'm going to change this to 6 over 1. Caitlin, can I cross simplify it all here?
Yeah. 6 and 2.
Good. How many times does 2 go into 6? 3. So on top I have 3 times 3, which is
9.
9. And on the bottom I just have 1, so my answer is just 9. Okay, my next problem looks a little bit different. I have 3 times x equals 3/4. So I am going to need to just do what here to get rid of this 3? Sammy?
You just need to do 3 divided by 3.
Yeah, I need to divide by 3. So I need to divide this by 3. I also need the fraction 3/4 divided by 3. Yes.
For a second.
Yes. Moving on. So we are dividing 3/4. Come back to me. 3/4 divided by 3. I'm just going to write that up here. Some of you might just do this on your calculator. If I'm dividing 3/4 divided by 3, remember when I multiply, what do I need to do, Mackenzie?
It's
3/4,
switch it,
switch it,
and then 1 over 3.
and flip it. Keep it, switch it, flip it. Can I cross simplify?
Yes.
Mm-hmm. 1 and 1, so I end up with 1/4. So here I get x equals 1/4. Okay, questions? Okay, I'm going to give you, I want you to try the 3 problems on the next slide, and I'm also going to pass out your worksheet to you.